Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak and this is Daily Quant with Deepak. Hi all, welcome back to day 53 of 100 days to CAT Quant series. In this video, we'll be discussing 5 questions from number system. So whenever a question is displayed on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video helpful, like the video, share this video with your friends who are preparing for CAT, and most importantly, for more such videos, subscribe to our channel. In case if you want to attempt these 5 questions in the form of a test, you can sign up in our portal, the gurukul.org.in. The link is provided in the description below. Once you sign up, you will get an access to a course called 100 Days Race to CAT, in which there will be 3 sections: Quant, LRD and VRs. We'll be uploading 100 tests in each section. So if you're a serious CAT 2025 aspirant, you cannot afford missing these tests. And these tests are absolutely for free. And if you want us to discuss any topic in particular, you can mention that in the comments below. We'll be doing a video on that topic as well, right? So without any further delay, let's get started with the first question. Now coming to the first question, the number of zeros at the end of 2 power 123 minus 2 power 122 minus 2 power 121 into 3 power 234 minus 3 power 233 minus 3 power 232. Now from the three terms, I can take 2 power 121 common. So if I take 2 power 121 common, you will be left with 2 square minus 2 minus 1. Similarly, from these three terms, if I take 3 power 232 common, you will be having 3 square minus 3 minus 1. So this is nothing but 2 power 121 into 4 minus 3, 1 into 3 power 232 into 9 minus 4, 5. Right. So we have something of the kind 2 power 121 into 3 power 232 into 5 power 1. Now when will we have 0 at an end? When you have a 5 and an even number. So that 0 will be nothing but resultant of 5 power something into even number, right? So the number of zeros will be always the lowest power of either 2 or 5, right? Now which is having the lowest power? 5. What is the lowest power? 1. So you will be having 1 0 at the end of the expansion of this expression. Now coming to the second question, what is the value of x for which x into the integral part of x is equal to 27, where integral part is defined as the highest integer less than or equal to x. Now for example, if we have the value of x as 4.5, when you apply integral function, the outcome will be 4. So we should be considering only the integer part, leaving behind the decimal part, right? So if I consider the value of x as 5, so 5 into integral part of 5 will be 5 only. So this is 25. Now similarly, if I consider the value of x at 6, so 6 into integer part of 6, that would be 36, right? So when the value of x is 5, you have 25, and the value of x is 6, you have 36. So this tells me that the value of x for which x into integral part of x is equal to 27, that lies between 5 and 6, right? So let me consider the value of x as 5 point something, 5 point y, right? Now we have x into integral part of x is equal to 27, right? So we have x into, if x is 5 point y, what will be the integral part of x? 5 is equal to 27, or x is equal to 27 by 5, which is 5.4, right? So the answer for this question should be 5.4. Now coming to the third question, the sum of the digits of a 4-digit number is 31. How many such numbers are divisible by 11? Right. So let the 4-digit number be A, B, C, and D. Now we have sum of these 4 digits to be 31. Right. Now what is the divisibility rule of 11? So the sum of the digits in units place plus hundreds place, right, minus sum of the digits in tens place and thousands place, right? That should be either 0 or a multiple of 11, right? So I can write this as A plus C minus B plus D should be equal to 0, or A plus C minus B plus D should be a multiple of 11. So let me write that as 11k. Now let me consider A plus C is equal to X and B plus D is equal to Y. Right. So A and C are digits. Similarly, B and D are digits. Right. So we have X minus Y is equal to 0. Right. And X plus Y is equal to 31. Right. We have, I can replace A plus C with X, B plus D with Y. You will be having X plus Y is equal to 31. Right. Now when I add these two, you have 2X is equal to 31, which implies X is equal to 31 by 2, which is 15.5. Right. Now can we have the sum of two digits as 15.5? No, you cannot, that cannot be in decimals. Okay. So this is not possible. Right. Now let me consider this case. So A plus C or X minus Y is equal to 11 or 22. Right. Or X minus Y is equal to 22. Now can we have X being sum of two digits and Y being sum of two digits? Difference, could that be 22? No. Right. Because the highest possible value of A plus C is 18 only, when A and C both are 9. Right. So the difference cannot be 22. Not possible. Right. So this is the only possibility where you can have A plus C minus B plus D is equal to 11. Right. And we also have X plus Y is equal to 31. Now adding these two equations, we have 2x is equal to 31 plus 11, 42, and this implies x is equal to 21. Now what is x? Sum of two digits A plus C. Right. Now can the sum of two digits be 21? No, we had just discussed that the maximum value of sum of two digits is 18 only when both the digits are 9. Right. So this is not possible. So you do not have any such number, four-digit number. When you add the digits, they sum up to 31 and divisible by 11. So the answer for this question should be 0. Now coming to the fourth question, how many natural numbers between 1 and 10 lakhs are perfect squares but not perfect cubes? So we are asked to find the number of numbers from 1 to 10 power 6 that are perfect squares but not perfect cubes. Now first let us find out how many perfect squares are there. Right. So from 1 to, I can write 10 power 6 as 1000 power 2. Right. So we have 1000 numbers that are perfect squares. Right. Now we need to find the number of perfect squares but that are not perfect cubes. Right. So what should be the form of a number that would be perfect square and a perfect cube? If we have a number in the form of x power 6 raised to the power 6, right? Now this is both perfect square and also perfect cube. Now we need to find the total number of numbers from 1 to 10 power 6 which are in the form of x power 6. How many numbers do we have? We have only 10 numbers. Now what are they? 1 power 6, 2 power 6, 3 power 6, 4 power 6, so on till 10 power 6. So we do not want these 10 numbers. So 1000 minus 10, 990 should be the answer to this question. Now coming to the fifth question, a natural number x leaves a remainder 1 when divided by p. The resultant quotient when divided by q leaves a remainder 2. The resultant quotient when divided by r leaves a remainder 3. And the quotient thus obtained is exactly divisible by 5. And that's not 0. If p, q and r are all natural numbers, find the least possible value of x. Right. So x when divided by p, let the quotient be a and the remainder is 1. So I can write this as divisor into quotient plus remainder 1. Right. And the minimum value of p has to be 2. Right. So your minimum value of p cannot be, or the minimum value of divisor cannot be remainder or less than the remainder. That has to be greater than remainder only. So I can say that p should be greater than 1. Right. Now similarly, quotient is a and this when divided by q you will get remainder 2. So let me write a as q into some b plus 2, right? And q should be greater than 2, your divisor should always be greater than your remainder, right? Now here the quotient is b and this when divided by r leaves a remainder 3. So r into c plus 3 and r should be greater than 3. And the quotient does obtain. So C is divisible by 5. So C is in the form of 5k. Right. Now what was asked? Find the least possible value of x. Now to find the least possible value of x, we should be having the least possible values for both P and A. Right. To have least possible value of A, least possible values for both Q and B, R and C should be having the least possible value. What is the least possible value of C? 5. Right. So when C is equal to 5, right. So into 5. Now what could be the least possible value of R? 4, because R has to be greater than 3. So 4 into 5, 20, 20 plus 3, 23. So the value of B is 23. Right. So value of B is 23. Q should be greater than 2. So the minimum value of Q is 3. So 3 into 23, 69. 69 plus 2, 71. So the minimum value of A is 71. And 71. What is the minimum value of P? P has to be greater than 1. Minimum value of P has to be 2. So 2 into 71. 142 plus 1. 143 should be the answer to this question.